I am dedicating these videos to a wonderful student, a wonderful soul who would always make my day every time I'd see them. So you know who you are if you're watching, and I hope these videos help, and I hope these videos help everyone else who's currently in Year 10. Had a handful of students also approach me later on asking me to, if I could somehow simplify and explain certain concepts in motion in Year 10 science. I'll say this and I'll say it again. Physics is not a difficult subject. It's not hard. The only thing that's hard is the mind, the human mind. That's the only complicated thing that complicates things. It's not hard. Physics, you need to visualize what's happening. If you can think in terms of pictures and imagine things, you'll be fine. And if you can work systematically, it's basically like a recipe. Every problem you get in physics is like a recipe. It's got steps to it. And if you follow these steps, you should be fine, hopefully. I'm going to start with the concepts of speed, distance, and time. I'm going to go to a very familiar idea, hopefully. Think of your car's speedometer. Okay, if you're in Australia, it goes from 0 to, I don't know, let's say 240 k's per hour. Don't do 240 k's per hour. It's not good. So 0 k's to, let's say, 240 k's per hour. So this thing in your car, if you look at it, it tells you the speed of the car. So there's no surprises there, but what does it actually mean? Okay, let's look here. Let's say, I don't know, 50 k's per hour. Suppose you're looking at the 50 k's per hour section. This means you are covering 50 k's every hour, every 1 hour. That's what speed is telling you. Speed is telling you how much distance d, okay, distance d in physics, you cover in a certain amount of time. In this case, every hour. Okay, this is time. And that's it. That's what speed is. That's all it is conceptually. Okay, if you picture what's happening in your car, if you put your foot down on the accelerator, if you're old enough to drive, that is, you will experience the car car speeding up, going from 0, let's say, to 50. Your speed's going up, so you're covering more distance in a certain amount of time, let's say 1 hour. So that's what speed is. Speed is how much ground, how much distance you cover in a certain amount of time. Because I'm a historian of science, among other things, I'm fascinated by history of science and how it's evolved over time, where these ideas come from. So it was actually the ancient Greeks who started thinking deeply about motion. They didn't really use much maths or maths at all, but they started thinking about it. Things like speed was somehow related to force. So if you apply a force to an object, like push it, it'll speed up, right? That's sort of logical. Then came the medieval thinkers, let's say around the 14th century. They started to think about motion a lot more. And then came Galileo in the 1600s. Galileo was a famous Italian physicist, scientist, mathematician, scholar. And he was responsible for coming up with a quantitative, so a mathematical way to express speed. Here it is, it's quite simple. Speed is equal to distance divided by time. It's a very simple concept. One of the simplest ideas in physics. That's your formula. You will hopefully get this in the formula sheet in the exam. Right, I'm 99% sure. Speed is given the symbol V, not S. Okay, V. We use symbols in physics and maths to make things easy. Okay, we don't like to write sentences and paragraphs, just symbols to make things easy. Distance has the symbol D, D for short. First letter, distance. Time, T, lowercase t. So in other words, mathematically, V is equal to D over T. So that's this expression here reduced to this thing here. It's much simpler. It's just quicker to write. Okay, we don't have time in science, in physics and maths to write complicated sentences, long sentences. This is your formula for speed. Now, it's V and not S because S has already been used in physics for something else called displacement. Okay, so V is typically used. V equals D over T. Let's look at some examples. So it's not good enough to just write this down and memorize this. You need to practice. Physics is not a spectator sport like maths. Physics and maths are not spectator sports, I should say. You need to practice. The way you commit this to your long-term memory, not short-term memory, your long-term memory. So you hopefully remember this in a couple of years, even if not more, beyond from now, is to practice. When you practice problems, write this stuff down over and over again, it automatically goes into your long-term memory. So you need to practice. So let's do some examples. I'll start simple and go a bit more complicated. So example 1. Let's do this slowly. Okay, suppose a person walks 200 meters in 50 seconds. What's their speed? Follow these steps. Step 1, given. And I'll use these steps for all years, whether it's, doesn't matter if it's year 7 or year 12, the exact same process. What are we given here? Look at the numbers. We're given 200 meters. So this is distance. Recognize that this is D. D for distance, 200 meters. M for short, okay? We're given time. 50 seconds is a measure of time. So T is 50, S, small s, S for seconds. We need to work out speed. What connects D, distance, and time T? Well, we know what it is. There's a formula for it. So we need, step 2 is we need V equals D over T. That's what we need. The third step is to sub and solve. Always follow these steps in any problem you get in physics. It makes life a lot easier. Doesn't matter how much practice you've got with these, even if you get this eventually, in an exam, on exam conditions, follow these steps. It makes everything less, you get less anxious, makes everything a lot less intimidating. Let's sub. So we know what D is, we don't know what V is, so we need to work out V. V is equal to D. D is 200 meters. Divided by T is time, 50 seconds. Calculator. Your calculator is your best friend here. 200 divided by 50 is 4 meters per second. That's what the divide means, this thing here, per second. You can also write it like this, with a -1. The -1 means 1 divided by the S, okay? But meters per second, like this, is fine. And that's how you do it. Let's say this was a 2 marker, 1 mark for the working out, 1 mark for the answer, and you must put units. If you don't put units, you lose marks. So that's a simple example here. Let's now quickly take a detour. I want to show something. Suppose you need to convert from 1 meter per second to kilometers per hour. How would you do this? Let me show you. Because you will be given problems that involve going between meters per second and kilometers per hour. 1 meter, let's use these facts. 1 meter is this many kilometers, okay? In other words, there's 1,000 meters in 1 kilometer. That's how you get this conversion here. 1 second is equal to this many hours. 1 over 3,600. Okay, because there's this many seconds in an hour. So 1 hour is 60 seconds times 60 minutes, and that's 3,600. Okay, there's 60 seconds in a minute, and there's 60 minutes in an hour, and you get 3,600. So in other words, 3,600 seconds is 1 hour. But to get 1 second, you divide both sides by 3,600. Just maths, that cancels out. So you get 1 second is 1 over 3,600 hours. So let's use these facts. 1 meter is this many Ks, and 1 second is that many hours. So 1 meter per second, let's plug it into this. So 0.001 times 1 over 3,600, so meters times hour, which is that, seconds, which is that, you get 3.6 kilometers per hour. 1 meter per second is 3.6 kilometers per hour. I suggest you memorize this conversion. 1 meter per second is 3.6 kilometers per hour. Another way to think of it, stairs. So Ks per hour, think of Ks as being bigger than meters per second, right? Meters per second is at the bottom of the stairs. Ks per hour is at the top of the stairs. To go from kilometers per hour to meters per second, you divide by 3.6. Think of going down the stairs, you're dividing, right? Going up the stairs from meters per second to kilometers per hour, you times by 3.6. Try and commit this to memory. This will help a lot in an exam. So that being said, let's do some more practice. Example number 2. Okay, a cyclist travels 10 kilometers in 30 minutes. What's their speed in kilometers per hour? This is where the conversion comes in. Okay, step 1, what are we given? Looking at the numbers, we're given 10 kilometers. That's distance. So D distance is 10 kilometers, km for short. Given time T is 30 minutes. However, we want kilometers per hour. Be careful here. A lot of students don't read this properly in an exam and they lose marks. You need it in kilometers per hour. We have kilometers, we need hour. How do we go from 30 minutes to hours? Well, we know that 30 minutes is half an hour. So it's literally half an hour. Number 2, we need, so how do we relate distance and time? Once again, it's through speed. V equals distance divided by time. 3, we sub and solve. V is D is 10 kilometers divided by time T, which is hours, 0.5 H. 10 divided by half is 20 kilometers per hour, and that's your answer. And I'll do one more, slightly tricky, not that tricky. Let's suppose a car is moving at 25 meters per second. What's this speed in kilometers per hour? Once again, step 1, given. We're given speed. 25 meters per second is V, speed. We need to go from meters per second to kilometers per hour. And how do we do that? Well, think back to the staircase. K's per hour is at the top. A kilometer is bigger than the meter. Meters per second is at the bottom. You're going down the stairs, you divide by 3.6. Going up the stairs, you times by 3.6. So number 3, we sub and solve. So in this case, or in other words, just solve. To go from meters per second to K's per hour, you do 25 meters per second times 3.6, because you're going up. And that gives you 90 Ks per hour. So that's how you use the formula. Speed V is distance D divided by time T.